Hi guys, in this video we're going to work on ellipse on section 8-2. So ellipse is one type of conic section we're going to work together, okay? So I'm going to show you how to draw an ellipse from the YouTube video. So let's watch the YouTube video together.
Two drawing pins pressed into the sheet and a string attached to them. To get the pins to grip, I have placed a piece of timber between the sheet of paper and the text square drawing board. The pins are located at the focal points of the ellipse. Start at one end of the major axis with the string taut and the pencil in contact with the paper. Draw the elliptical curve. This is a very smooth way of drawing an ellipse, but not suitable for an examination situation. The string is the length of the major axis.
Okay, so as you guys see that the ellipse is drawn by using the attached pin and then the string. So actually, the definition of ellipse is the set of all the points in a plane whose distance from the two fixed points in the plane have a constant sum. That's why that they already started with the the pins and the line, pins with the string, so that you're going to use your pencil to draw around it. The sum of the distance from the faces and then point would be exactly constant. So he mentioned on it the two fixed point we call the foci, which is a plural of focus, and then the line through the foci we call it as a focal axis. The point on the focal axis midway between the foci we call the center. And then the points where the ellipse intersect its axis are the vertices of the ellipse. So in here, you may see on the picture page 559, 51, and the figure 8.11 indicates that good about all the vocabularies. Okay, so we have a two points here. We call the focis. That's focus. That's a focus. Now this we call the center. Now your ellipse is gonna be look like, I know I'm just drawing with my hands. It's not really look perfectly, but that we call as an ellipse. And then those points, this we call the vertex, and this is we call the vertex. Okay. And then we call this line from here, we call the focal axis. So this is going to be our focal axis. Okay? So now you should know the standard form of the equation of ellipse. You guys may see in the page 592. So you have two situations. You're having your focal axis is the x-axis and y-axis. So you have to think about both of it. So the equation x squared over a squared plus y squared over b squared equal 1, that one we can say the focal axis is the x-axis, which I just showed you before. Okay, so that would be briefly looks like your graph, your ellipse looks like this. Okay, now your ellipse looks like this. Then it will be y squared. Y goes first. Y squared over a squared. A and b is not going to be changed. Plus x squared over b squared equal 1. That one we call as our focal axis as a y-axis. Alright, so you should know that what is going to be the, we're going to have a new vocabularies coming up in here. So let me explain after you explain the form, and then I'm going to explain that. So, after that, we should find out our foci, which is, plural of focus. So, focus, we're going to use a letter C. So, foci, you're going to have two of it, which is plus or negative C, comma 0. As you see that the center is going to be the middle of it, they have, C and then the negative C. This is working for the x-axis. The opposite situation, if you have a y-axis, your focus, which is a foci, would be 0, comma, plus or negative C. And vertices. Your vertex is what? Located on your x-axis, which is the intersection of x-axis. We can say that would be plus or negative A, comma 0. Okay? And your vertices is on the y-axis. Still, we're going to use, A, but it's going to be changed on to 0, comma, plus or negative A. Okay? Now, you guys have a semi-major axis and then the semi-minor axis. You should know what is the major axis and minor axis. So please look at the page 592 all the way top. So, we know the chord. Chord is a line segment with end point. That's what we call the chord. You guys learned the chord from the circle as well. But in here, the chord lying on the focal axis, we call the major axis. So think about it. Your semi-major axis, which is a major axis for the first case, is x-axis. You are going to use A for your semi-major axis. Which means what? Your major axis is going to be 2A. So, semi-major axis, that's going to be A. And then the semi-minor axis, that's going to be B. This is major and then minor. So, minor axis the opposite way. It's the chord through the center perpendicular to the focal axis. That's gonna be minor axis. Okay? So now, the opposite situation, your focal axis is a y-axis. Still, your semi-major axis and minor axis is not gonna be changed. So, A and B. Now, you need to think about your C. Okay, so what's gonna be C? That is the thing. So, they show us the Pythagorean relationship all the way bottom. And they ask us to see the figure 8.15. So, at this time, your expression would be A squared equals B squared plus C squared. It's gonna be applicable for both situations. But now, I want you to get my C. So C this time would be C squared would be A squared minus B squared. That's why we need to look at it. Okay? So, we're going to practice to find C from this. So that after this, you're going to put what? Square root of it. Your C would be plus or negative square root of A squared minus B squared. So we are going to have a plus or negative of C. So, you can just take up as a one value, positive, and you can cover it of the both of it. So that is the expression that you have to remember. C squared is going to be same as A squared minus B squared. I'm going to show you why it's going to be happening on figure 8.15. So when you guys draw the situation here, you're having an ellipse like this, and this is gonna be your foci, negative C comma 0, positive C comma 0. That is gonna be C comma 0. So this side would be C now, correct? And then you are going to have a semi-minor axis. What's gonna be minor axis? That is gonna be B right here. So you guys make a triangular shape, and we're going to label as a. Then you can make your Pythagorean relationship easily, which is a squared. A is a hypotenuse, so it's gonna be b squared plus c squared. Okay? And then the other situation, your ellipse, your major axis, which is a focal axis of your ellipse, is a y-axis. Your graph, your ellipse looks like that. All right? And still, our minor axis is gonna be x-axis this time. That's gonna be relabeled as a b. Now we have a focus here, 0, c. So I can get my value c here, then you can connect the 2 points and you can get your a. That's why still your a is on the hypotenuse, so we always think about your c squared equals a squared minus b squared. That's what you need to remember. All right? Okay, so now I already done for everything. All right, so I'm going to move on to the example 1 now. I am on page 592, example 1. Finding the vertices and foci of an ellipse. Find the vertices and the foci of the ellipse for x squared plus 9y squared equals 36. Okay, so I'm going to show you how we change this into the standard equation of ellipse. Look, when you guys go to the, the standard equation of it, we have x squared over a squared plus y squared over b squared is always 1. So you should make a 1 from 36 by dividing. So you're going to divide everything by 36. Then you would have x squared over 9 plus y squared over 4 equals 1. Alright? So that's going to be our standard equation, but look, which one goes first? X squared goes first. And then, look at which number is a bigger number. A and B. So, my bottom one, 9, is a bigger. So, your focal axis is gonna be the x-axis. So now I have my a is 9 square root of 9, which is 3, and b square root of 4, that's gonna be 2. So now I can get my c by plugging the formula. What was it? C squared equals a squared minus b squared, which is a 9 minus 4. That is 5. You are going to plug in c into the, radical 5 so that you can get your foci. And this, your major axis is x-axis, so that you're going to put plus or negative c here and then comma 0. Okay, now vertex. This is going to be my foci. And this is my vertex. Vertex is what? A, comma, 0. And negative a, comma, 0, which is your major axis. So plus or negative 3, comma, 0. So when you are talking about your standard form, your a and b, if your a is bigger, then that is going to be your major axis. So in this time, your a is 3, b is 2. 3 is bigger, so your x-axis is going to be your major axis. So always in your formula of ellipse, a is always bigger than b. Okay? Alright, so we are going to work on exercise 1 together on page 599. Number 1. So find the vertices and the foci of the ellipse. So in this time, I have x squared over 16 plus y squared over 7 equal 1. Okay, it's already written as 1. Then I can get my a and b. As I said, a is always bigger than b. This is your a. This is your b. Correct? Actually, a squared and b squared. Now I want to get my vertices. Vertices is what? A plus or negative a. A squared is 16, a is 4. So you're having plus or negative 4 comma 0. That's your vertex. Now c. I have to get my c. So c squared is a squared minus b squared, which is a 16 minus 7, which is what? 9. So if you plug in, if you put the square root each side, that's gonna be 3. So I can say my c would be plus or negative 3 comma 0. Okay. Alright, I hope this video helped you to understand. I think that's the last video before Zoom class. So if you have any question, you're going to ask me tomorrow in the Zoom class. Thank you. Bye.